Hello and welcome back. In the last video, we talked about monolithic architecture, the benefits and the challenges of monolithic architecture. Now, in this video, we are going to also talk briefly about microservices architecture, which is the architecture that will be used to build the application we intend to build. Now, microservices architecture is newer architecture compared to the monolithic architecture. And as you know, monolithic architecture involves you building your software as a single unit. Microservices architecture, on the other hand, involves you building your subdomains as separate services. So let's see what the definition is. Microservices architecture is an architectural style that structures an application as a collection of small, independently deployable services. Unlike monolithic, where you have all your subdomains in one unit, here in microservices, those subdomains can be structured as independently deployable services. Now, if you look on the right, you can see here just a simple overview of how the architecture of a microservices looks like. Okay, so you have your clients. Now, this clients could be web browser, could be mobile. Okay, and then you have the API gateway. Now, this is just one approach. In some cases, you might see a direct client to microservice architecture, but we are not doing that. We are not going to do that. Our communication will be client to API gateway and then API gateway to microservices. Okay, so here you have the client, then to the API gateway, and then the API gateway to the microservices. Now here, each microservice will have its own technology stack, will have its own structure, will be connected to its own database. Here, they don't have a shared database. Each service will have its own database. So each service will be handled as a separate application. Okay? In microservices, each service will be handled as a separate application. So for example, an e-commerce application, you will have your authentication feature as a separate service. You have your products as a separate service, your payments as a separate service, your orders as a separate service, and each of them will have access to its own database, not a shared database. So this is an architectural style that structures applications as a collection of small, independently deployable services. The microservices architecture is oriented mainly to the back end. Yeah, so it's used mainly on the back end, but recently the approach is being used for the front end. There's this new concept of micro front ends. Okay, so you can break up your front ends as micro front ends instead of just having one large front end application. You just break them, so each of maybe the components will act as a front end on its own. Okay, so it's oriented towards the back end, but the approach is also used on the front end. Now, services communicate via well-defined APIs. Okay, so there are different modes of communication. There are different types. You have the microservices. You can have the synchronous and the asynchronous. We are going to talk about that later. And you can use REST APIs. You can use GraphQLs. You can also use WebSockets for communications. Okay, between the client, the API gateway, and the microservices. And then you can also use events, which is the approach we're going to use for communication between microservices. Okay, we are going to use the synchronous and asynchronous approach. Communication uses protocols such as HTTP or HTTPS, WebSockets, or the Advanced Message Queuing Protocol, AMQP. We are going to use that for our events when we implement RabbitMQ. Okay, so this is just the basic idea of what a microservice architecture is. And then lastly, API communication could be direct, client to microservices, or API gateway pattern. I already said that. You could see some architecture whereby the communication from the client, maybe the browser, the mobile application, is direct from the client to the microservices without having an API gateway. We are not going to take that approach. There's not going to be any communication directly from the client. all communications in our own application will pass through an API gateway. Now let's talk about some of the benefits of microservices architecture. Scalability. One benefit is scalability, okay? Microservices allow each service to be independently scaled to meet demand for the application feature it supports, okay? So one part of the application could be experiencing some peak demand, and then you could scale that particular service without affecting the other services, okay? So you can scale that, you can scale in or you can scale out, that is add more resources, or if it's not experiencing any peak, you can remove resources. So one benefit is scalability. You can scale individual parts of the microservices independently without affecting the other parts. Now, faster development. Now, for this, teams can work on and release individual services independently, leading to faster development cycles. Okay, so probably the team working on the authentication feature could be faster than the team working on the payments feature or the product feature. Okay, so this leads to faster development cycles. Now, for this, there is flexibility in technology stack. Unlike monolithic architecture where the application uses only one technology stack, here there is the flexibility in technology stack. This allows teams to choose the best tools and programming languages for specific tasks. Okay, so the team building the authentication service could decide, okay, I think Python will be best suited for that. The team building the payments could decide, okay, we're going to use Java. The team building the products service could say, okay, .NET is best suited for it. Okay, so there is flexibility in technology stack. And then fault isolation. Now, microservices are designed to be fault tolerant. So if one service fails, it doesn't necessarily bring down the entire system. Unlike monolithic, if one part fails, it could bring down the whole system. So maybe if the payment system is faulty, okay, the authentication system will still be working, the product list. The only issue is users won't be able to make payments. Okay, so fault isolation is a benefit. Then another benefit is improved maintainability. Smaller services are easier to understand, maintain, and update. Okay, unlike if you have a very complex application built with a monolithic architecture, then if a new developer comes into the team, you have to try to understand as much as possible. Unlike if you're using microservices, you just only have to understand the domain or the services you are working on. You don't really need to know the inner workings of the other services, only just focus on the service you're working on, and thereby making it easier to maintain. Isolation of data. Microservices can have their own data storage solutions, which can lead to improved data isolation and security. Now, for this, we are going to use the database per service approach. Okay, so each service will have its own database, will manage its own data. So we use the database per service approach right here, and this can improve data isolation and security. Now, enhanced monitoring and observability. Now, this is very important. Okay, if you have a microservices application, it's important that you have or you set up monitoring and observability. So each service can have its own monitoring and observability tools, making it easier to track performance, troubleshoot issues, and gather insights into the behavior of a system. You can use different monitoring tools for each service, or you can also use just one tool, but inside that tool, each of the services will be isolated, which is what we are going to do. We are going to use one tool, which is Elasticsearch and Kibana for our monitoring. But inside Kibana on the dashboard, we'll be able to see each services, their own logs. We'll be able to see the logs. We'll be able to monitor each services separately. And also we have ease of deployment. Microservices enables continuous integration and continuous delivery, making it easier to try out new ideas. Okay, so because Each services have their own pipelines. You can deploy them independently of other services. Let's talk about the challenges of microservices architecture. Operational complexity. So managing a large number of microservices can be operationally complex in terms of infrastructure, tools for deployment, monitoring. Now, if you have a very complex application built using this microservices architecture, it could be complex to manage because you have too many services. Inter-service communication. Now, the inter-service communication involves communication between microservices, not communication from the client to the microservice, but communication between microservices. Now, this depends on network communication. So if not properly built, there could be issues with latency, reliability, and data consistency. Now, testing and debugging. Now, testing microservices individually and ensuring proper integration can be challenging. And debugging issues that span multiple services can be complex and time consuming as well. So if you have a very complex application, it could sometimes lead to probably testing and debugging issues. Then we have security and compliance. Now, security can be more challenging in a microservices environment as there are more potential entry points for security breaches. Okay, so you have to take into consideration security and compliance. For the application we are going to build, we are not going to allow requests or communications into our services from the outside world. Communication into the service will all pass through the API gateway so as to improve security. And then monitoring and observability as well. So monitoring multiple services can be complex. There also could be issues with team communication and collaboration.